This week's episode is sponsored by NVIDIA.
You're listening to the B&H Photography Podcast. For 50 years, B&H has been the professional source for photography, video, audio, and more. For your favorite gear, news, and reviews, visit us at bnh.com or download the B&H app to your iPhone or Android device. Now here's your host, Derek Fassbender.
Welcome, listeners. I'm Derek Fassbender, host of the B&H Photography Podcast.
And I'm Jill Waterman, the podcast senior creative producer.
And I'm Mike Weinstein, the show's technical producer and audio engineer.
At its best, photography draws from both science and art to give resulting images a dual purpose, aesthetic innovation and scientific merit. And when that photography happens from the windows of the International Space Station, capturing star trails, city lights, and our blue planet against the void of space, it becomes something truly transcendent. In today's show, we're privileged to chat with a scientist, inventor, and photographer who has spent nearly 2 years living, working, and making pictures in orbit. But before we take off, here's a bit more about our distinguished guest. Donald Pettit is a NASA astronaut and a veteran of 4 space flights, logging more than 590 days in space, primarily on the International Space Station. Currently NASA's oldest active astronaut, Don's missions have focused on scientific research into topics that include microgravity, 3D printing, water purification, and plant growth. He's also known for his remarkable in-space inventions, stunning astrophotography, and engaging educational content that makes space science fun. A native of Silverton, Oregon, Pettit was selected as an astronaut candidate in 1996. He holds a bachelor's degree in chemical engineering from Oregon State University and a doctorate in the same field from the University of Arizona. Prior to joining NASA, Pettit worked as a staff scientist at the Los Alamos National Laboratory in New Mexico. Dr. Donald Pettit, welcome to the show.
It's a pleasure to be here, Derek.
It is beyond a pleasure. I mean, I think I speak for the rest of the team and probably a lot of our listeners. There's photographers you talk to and it's like, okay, there's a lot of headshot photographers, a lot of fashion photographers. This is a rare treat for us to have somebody who takes photos from a place that most of us will never even see. So absolute pleasure to have you on. I want to go back to when you first got into photography. I know you have been taking photos since childhood, back with the Brownie camera. Can you talk about what it was about photography that drew you in at an early age?
I don't know. It's just, why is blue someone's favorite color and red is another person's favorite color? I just was drawn to photography. I liked the technology about it, even though the Brownie camera just had one button and you pushed it and it went click. Loading the film, I think it was 127 film. If you didn't put it in right, it jammed in the camera, and then you got to take the film out and develop it. Just the whole process, as well as looking through the little viewfinder and figuring out how you wanted to compose the picture. I loved it all.
Was there a point where it hit you like, wow, I really love this? When we get older, we start to understand it more and see the impact of our photographs. Was there a point you remember that kind of stands out that you knew this is something that would be with you for the rest of your life?
Yeah, that was, from the Brownie, I moved up to a secondhand Zeiss Icon camera, 35 millimeter film. And then from there, I spent all my money from a summer's worth of work in a cannery, and I bought a Nikon F with the FTN finder. And I couldn't afford the f1.4 LED, so I got the f2.8 LEDs, 50 millimeter. And that's when I really started to get into photography, developing the black and white film. I would buy out-of-date bulk 100-foot spool film from a mail order place, and I'd reload it into the 35 millimeter snap caps. And I found I could get 40 pictures in a can instead of the standard 36. And anyway, that's when it all took off.
Wonderful. And now, being that your background is steeped in a lot of science, is there anything that you've drawn from your traditional learning in chemical engineering and the sciences that has led into your artistic vision?
Well, chemical engineering is a good set of tools. I love chemistry and I love the chemical engineering tools that come with it. And I have used those throughout my career to solve various problems. And if you think of spacecraft as being aerospace mechanical engineering, which for the most part it is, but once you get into space and you got human beings inside this can, how do you make air? How do you purify water? How do you remove the CO2? All of these processes are just standard chemical engineering processes. We call them unit operations. And that's what makes it possible for human beings to live in a spacecraft is chemical engineering.
Mm. Yeah, it's funny. I've always thought of you as much as an inventor, as a wonderful standout photographer. And I think photography, there's a lot of inventive nature in photography and trying to see differently and create different things. It's mind-boggling to me. You think about the traditional film process and how most people did it, where you're taking field notes and trying to learn from your mistakes, and you got to drop your film off and you don't know what you have. That's difficult enough when you're just dropping your film canister off at the little 1 hour photo. But when you're in space and you have to come back, what was it like to try to learn from mistakes or not know what you have and you're not even on the same planet?
Yeah. Well, on my first flight, this was 2002, 2003, a 5.5 month mission to station. We started off with a combination of film and digital camera. And at the time, we had the state-of-the-art professional level camera. It was a Kodak Nikon product, the 760, and it was, I believe, a DX size sensor. And then we had the F3, I believe, a film camera. And then we had Hasselblad with a 70, I think it's 70 millimeter back on it. We had a capacity to have like 100 frames with this film back. And we took mostly film pictures up until Columbia happened, which was February 1st, 2003. And after that, we knew that shuttles weren't going to fly for a long time. We were on station and we stopped using film because we knew that it would stay on orbit for a long time and the cosmic rays would fog the film. And we switched to our digital still cameras at that point in time.
And what kind of preparations can you make? I mean, you have to, with all the information out there, it's still a different environment altogether. And how do you learn from these mistakes or prepare for a flight when you're here in a completely different spatial, situation? How do you prepare for what you're going to face up there and taking images? Was there any challenges that stood out or that really piqued your interest for solving these creative I guess, conundrums?
To prepare for spaceflight takes a lot of work on the ground. And we have at Johnson Space Center one of every kind of camera and lens that we use in space. And you could check them out like for the weekend, take them home, take pictures of your dogs, your kids, go to the Little League games, do whatever you want. And you learn how to use the cameras. And when we had film, we had the same kind of film we had on orbit. And you could take as many pictures as you wanted and bring them all back, and then the film would get developed. And the most important aspect is we have a photography group. We call them photo TV trainers. And they would review our film in front of us and tell us what we did wrong, what we could do better. We would get critiqued. They would also be our trainers in terms of teaching us how to use these professional level cameras. And through a process of doing that for maybe 2 years on the ground, you get good at using the equipment. And then when you get in space, the learning curve changes a little bit to get used to that environment, but it's not as big a learning curve as just figuring out, how do I turn this camera on? I'm in space. I want to take a picture.
Wow, that's so interesting. I didn't think about the all that goes into just the critiquing and how much the images. I mean, are the photographs that you're getting, is everybody well versed in this? Or is it some that stand out a little more and like, hey, Don's the photographer here? Or is it really everybody has the same general skill set as far as photography?
The basic skill set is the same in terms of here's our camera, here's how you pick it up, here's how you turn it on, what mode do you want to go into, that kind of thing. But as you know, there's a span of, call it composition skill set in any group of photographers on Earth, and the same thing you'll find when you get into space.
Mm. Early on, particularly more in the film days and when you were shooting film, what was the success rate like? I know a lot of us don't have a very good film success rate. You go back and out of 36 pictures, you might have 2 that you kind of like. What was the success rate for you? Was everything amazing just because of the perspective?
No, the orbit environment is significantly different than Earth. That standard metering, like the matrix metering, that works well for Earth lighting, but you get into space and you look at Earth from space, you might have 2/3 of your frame just black, 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 because it's space, and 1/3 of the frame is Earth, and it's bright blue or bright brown or whatever you happen to be in terms of part of the Earth you're over. And the matrix system gets fooled by that. It's not what it was designed for. And we use bracketing a lot. If you want to get a good picture, I would set the cameras on high speed and then set bracketing to 1 under on and 1 over. Sometimes I'd set it to taking 5 pictures where it would be a 2 under, 1 under, a meter, and then the same for overexposed. And this ensures that you will get a good exposure for what you want to capture.
Mm. But how much of this was creative versus, hey, we need actual documentation of certain things? Did you guys go up with shot lists and then have time to say, hey, this is kind of cool. I want to kind of step outside the box and create a little here?
Yeah, we don't go up with shot lists, but we get instructions on a daily basis. And the kinds of things that we need to take photos of are engineering targets. Like we have an electrical issue with a piece of equipment and you disconnect all the cables, and then you take pictures of the electrical connectors, both the plug and the socket. And it's a macro kind of photography. Or you are tasked to take pictures of the solar panels from various windows we have on station, or the radiators, or some of the truss structures. So most of the task list imagery are, I'll call them boring engineering topics, plugged filters and electrical connectors and a micrometeorite damage in solar panels and things like that. They're not necessarily requiring any kind of creative composition. It's just you need to expose so that we can record the damage or the engineering information needed. So anything beyond that is typically left up to the crew member.
Okay. And your star trail photographs, I mean, some of your most iconic work. Can you talk about the setup? I know there is a barn door tracker that you manufactured from scavenged materials. Can you talk about building that and how this idea came about and how your work ultimately was affected by that?
Yeah, a couple of topics. One are 30-minute time exposures. And 30 minutes is about the longest time exposure you could do because that's the length of the real dark phase during our night passes. And in that 30 minutes, you go about 1/3 of the way around the Earth. So you get some pretty cool pictures by having the shutter open for 30 minutes, which of course you don't actually do unless you're having film. With digital cameras, you'd use a series of 30-second exposures and then stack them afterwards. The barn door tracker, that was meant to counteract orbital motion so you could take sharp images of cities at night. And this was based on the Nikon Kodak 760 camera, where ISO 800 was the maximum ISO you could actually use it at. And it would take a 1.5 to 2 second exposure to get a good image of cities at night, and they would always be blurry. And this barn door tracker allowed me to manually track the cities while I took these 1.5 to 2 second exposures and get consistently sharp images of cities at night. And that occurred in the 2002, 2003 timeframe.
Wow. It must be nice to be able to see an issue and know, and you have that drive. You like figuring things out. You like problem solving. I think that's at the core of anybody who's an inventor, right?
Yeah, I do like problem solving. And I think it was Jonathan Swift that said, necessity's the mother of invention. And you just take the cities at night, you look at them with your eye, and even though it represents a form of light pollution, they are incredibly beautiful from an orbital vantage point. And when I saw that, it's like, I want to try to capture that on imagery so I could share it with other people. And that's what led to the barn door tracker mechanism. And now with our modern digital cameras, you could crank the ISO up to whatever you need, and you could do handheld imagery. But back then, you needed the barn door tracker in order to get a sharp image.
Is the barn door tracker your ultimate accomplishment as far as improvising photographic equipment, or is there anything that you improvised or invented up there that you're like, wow, this one put me to the test?
Yes, on my last mission, I brought what I call an orbital sidereal tracker. And a sidereal refers to the rate at which the stars move. Uh, and if you have a telescope or something and you've got a tracking mechanism on it that counteracts Earth rotation so that you can point the telescope at a collection of stars and take a nice long time exposure. And that's what is meant by a sidereal tracking system on Earth. And I devised one with the help of some friends from Rochester Institute of Technology, RIT. We made a mechanical wind-up clock that the hour hand turns once every 90 minutes instead of once every 60 minutes. And 90 minutes is our orbital period. So that counteracts the orbital motion so that if everything is lined up correctly, you could take time exposures with a star field and have the stars as pinpoints instead of streaks. And this allowed a factor of 60 times longer exposure than what was previously possible without a tracking system.
Wow.
And on my last flight, I was able to really get what I think are great compositions of the Milky Way with zodiacal light, the soon-to rising sun, all on a Earth horizon view, a composition that's impossible to make if you are boots on the surface of Earth.
Completely fascinating. I mean, just to have at your fingertips right there, stuff that we'll never see other than through images like yours. We talked a little bit about your gear that you had taken up in the early missions. And as technology advanced, obviously it got easier. What was the first mission where you remember, wow, the technology has changed so much, this makes my life so much easier in terms of photographing? Is there one that stands out?
Yeah, that would have been the 2002, 2003. Again, that was a combination of film and the then state-of-the-art professional level digital cameras. By the time 2008 rolled around, when I did a 60-day shuttle mission going to the space station for construction purposes, we had the Nikon 2X, and that was a game changer in terms of upgrading the digital camera technology. And because of Expedition 6, the 2002, 2003, and Columbia, that basically killed film. So after that point, NASA stopped flying film in space and switched entirely to digital format. So by 2008, when that rolled around, we were using the state-of-the-art digital cameras at that point in time. And that really changed what you could take a picture of.
Mm. And now I know you have the instructors in Houston to help with the technical planning of photographs. How much are they involved, and how much were they involved with the technological advances? As the technology increased, were they less involved, or how did that work?
They're the main people pushing the new technology because these are professional level photographers that are our trainers. Many of them are from RIT with degrees in imagery science, and they are aware of what the latest state-of-the-art advances are, and they're the ones that push the program into obtaining and updating the camera equipment to the state-of-the-art. So they're working behind the scenes to make it possible for people like me to take the cool pictures.
So they're loving the technology. They were the ones that were celebrating the technology probably the most.
They were, and not only do they celebrate the technology, they continue to work with us while we're on orbit. They will send us emails because the digital imagery comes down on a daily basis, and they will review it, and they'll send you a message back saying, hey, you're overexposing your pictures a little bit, you're blowing out the whites, you need to add a little compensation to your imagery. Or they'll let you know that, hey, the focus is a little soft. You need to make sure you pay attention to focus. So we get continuous feedback from our trainers.
Are they the ones setting up the group photos? I remember you speaking some years back, and that was one of the parts I belly laughed at was, this is how the in-shuttle picture looks to me, but this is what they expect to come out of it, and it's all stacked in rows like a school picture.
Yeah, they train us on the ground how to do crew shots. And you think, oh man, isn't it easy? Everybody just lines up and you take a shot. And on orbit, there's some details that are a little different than on Earth. And when we're trained, because we're on Earth, everybody's standing, and we'll practice doing crew photos on Earth. When you're in space, you can be oriented any other direction you want. But one thing that does happen, you'll have everybody lined up in front of the camera. And maybe the camera is 15, 20 feet in front of the group, and you got somebody setting the camera up with a time delay, and they get the time delay and they quickly fly into the group to get in place before the timer goes off, and they act like a bowling ball going into an arrangement of pins, and you just completely make the whole group fly apart, and that's, of course, is when the shutter goes off on the camera. So that kind of thing doesn't happen on Earth.
You would hope not, right? Oh, man. What are the images that you come back with? You had once said in a podcast that when your mission is over, it's photographs and memories. That's all you have. When you come back, what are the images that are most meaningful to you when you look back through your archives?
The special images that I helped advance in the technology, like coming back from Expedition 6 in 2002, 2003, it was the cities at night and the first long time exposures, and those were all on film. And then moving on, some of the starfield pictures, and then the star trail pictures. These are ones that seem to speak to me when I go and review my photos. Crew shots are great. Anybody can take a good crew shot, or anybody can take a bad crew shot, and there's a lot of those. and it's good to see pictures of you and your crewmates, but it's the imagery out the window, particularly the nighttime imagery, the imagery that's really difficult to capture. Those are the kinds of pictures when I look back that I smile the most at.
Do you end up being out of 90% of the photos, or do you make sure that you get in a fair amount?
Yeah, there's not that many good pictures of me in space because I'm always behind the camera. And it's not uncommon when somebody takes a picture of me, they do just like we're trained. They focus on your face and then they shift the camera over for composition, but they unfortunately let up on the shutter button so that it refocuses on the bulkhead behind you. And then when you look at the picture, my face is always a little bit soft on the focus, but the cables and the labels on the bulkhead are in sharp focus. And that seems to be my lot in life.
I want to talk a little bit more about the technological aspect because I think it's something that, again, most of us won't understand the differences as far as the gear is concerned. Everyone's carrying a cell phone now with a mobile camera. Has that aspect of the technological shift carried over to space photography, or is it still there's certain parameters that you need on those cameras that are functioning for a specific purpose, a specific environment, or are you able to take, a camera that everybody would use here and just send it right up to space and it's going to function the same?
Good question. How do we balance between, say, iPhone, iPad kind of technology versus a full professional level camera? We use and are trained to use the full professional level camera. We always shoot 14-bit RAW, and because of the difficult lighting that you can find on orbit with huge dynamic ranges, the 14-bit files can preserve detail on either end of the scale, where shooting a standard JPEG or HIAC file will not preserve that detail. And you never know when there's going to be something in the shadow that you really want to bring out. And if you'd shot it as a JPEG, you would not be able to extract that information.
Interesting. So the same questions that we're answering down here as professional photographers, but just I think at a higher level.
I shoot a lot of pictures with my smartphone, and I love that you can have like 3 different lens types on your iPhone, and I use them, and I like to shoot the RAW or the HIAC, and then you can download an app that allows you more independent control. These things are all good, but gosh, when you're in a situation that perhaps it's a once-in-a-lifetime situation. Maybe you go to Antarctica, or maybe you get into the Atacama Desert region of Chile, which, by the way, I just came back about a week ago from that region in Chile, and I took snapshots with my smartphone, but all the wide-field astrophotography imagery that I did that with professional-level cameras shooting 14-bit RAW. That's what I like to shoot. I've seen some space missions where they primarily use nothing but iPhones for their imagery. And because of the challenges in lighting, the images from my view did not properly reflect on this once-in-a-lifetime experience.
I got to ask, Don, what's your everyday? When you're going out and you're with the family or you're going on vacation, what's your personal camera?
Okay, I went and bought the same kind of camera that we are currently using on space station. And even though I could check one out, I wanted my personal camera, and it's a Nikon Z9.
Nice.
And I still have a bunch of the older FX lenses. I'm slowly upgrading to the Z-mount lenses.
Wonderful. Well, this seems like a good time to take a short break. So let's stand up, stretch, shake it out. If you're already standing, have a seat, relax. And when we come back, we'll continue our conversation with the nonstop scientist, Donald Pettit.
Upgrade to advanced AI with NVIDIA GeForce RTX GPUs and supercharge everything you do. Play graphically demanding games at higher frame rates, render 3D and video content faster, and work smarter with productivity-enhancing generative AI assistants and AI-powered apps. Plus, with incredible on-device AI performance powered by dedicated NVIDIA AI processors, your data stays secure on your PC. NVIDIA powers the world's AI, and with RTX GPUs and Windows PCs, it also powers yours. Head on over to bnh.com for more information about NVIDIA products or use the link in our podcast show notes.
And we are back with NASA astronaut Dr. Donald Pettit. Now, Jill, I know you want to dive into the gear a little bit more. Talking cameras, lenses.
Yeah, Don, I understand that you are a big fan of very fast lenses and that you even were able to get Nikon to make a special lens to use in space. Can you tell us about that?
Well, yeah, I am a fan of fast glass. And that's primarily because I like to do nighttime imagery. And on orbit, the world moves by really fast. So there's upper limits on shutter speeds, a quarter of a second if you don't want to have significant blur. And then if you want to keep noise under control, ISO 6400 is about my upper limit for making really low noise images. So once you set a quarter of a second and ISO 6400, the only thing you have left to play with is your f-stop. And an f2.8 lens, which is not an uncommon kind of lens, particularly for wide angle, that's 4 times slower than an f1.4 lens. And for my last flight, I was able to talk NASA into buying a couple of wide angle lenses that are f1.4, or in one case, a T1.8 lens. It was a prime cinema lens. And this really advanced my ability on this last mission to do imagery at nighttime.
Fascinating. So you also mentioned just before the break that you're now shooting with mirrorless cameras. At what point did the shift from DSLRs to mirrorless happen? And was there a market change or adjustment in quality from that?
Yeah, when I saw the industry was changing to mirrorless cameras, I personally fought that kicking and screaming. It's like, I need my viewfinder. How can you arrange your composition, particularly in low light, when you can't actually see through your lens? And so I fought that kicking and screaming. And then I started training with the Z9 camera. And it didn't take more than a couple of weeks of using that camera to say, hey, this is pretty cool technology. And after flying in space with the Z cameras, it's like, I don't want to go back to these cameras that flop a mirror back and forth and vibrate the camera all over in between shots and things like that. So I am slowly upgrading my collection of FX lenses to Z lenses, and instead of kicking and screaming with the new technology as it comes in, I got converted and am embracing it.
Don, what's the most interesting otherworldly phenomena that you've been able to capture? Is there anything that stands out as your favorite subject matter while you're out in space?
Yes, a couple of things on this last mission, and realize I've been looking at Earth from space since 2002. And to me, on this last mission, 2 big changes that were not there before. One is LED lighting for city lights. City lights in the past were all yellow-orange from sodium vapor lights, or bluish green from mercury vapor lights. Both of those were common lighting that you would see in cities all across the world. And now those kind of lightings are decreasing, and you see LED lighting, and the LED lighting is either bright white, or pastel colors. There's pinks and blues and greens and colors across the spectrum, particularly in Asia. They seem to like all these different colored lightings in their cities. And it's beautiful from orbit, but also realizing that this is a form of light pollution that's even harder to filter out if you're doing astronomy, because you can't use line filters anymore to knock out the sodium D lines, for example, or the mercury vapor lines, because the LED lighting is more broad spectrum. So it's like so many double-edged swords. In some respect, it's good. In some respect, it's bad. So that's one of the things that has significantly changed since 2012. The other is Starlink satellites. There are literally thousands of those, and they're really, really bright from an orbital perspective. And you see them plus or minus 10 degrees from the sun, either before sunrise or after sunset. And these things can be brighter than Jupiter, and you will see hundreds of them flashing in front of you while you're taking these nighttime images. And I've gotten to call them cosmic fireflies.
Yeah, I had a lesson on them this past summer when my 8-year-old son thought he was seeing shooting stars. And he's like, so many moving things. And I didn't realize when you really sit there and look up at the sky from a non-light polluted area, you realize how many are out there.
Yeah, and they are designed to try to minimize their signature from the surface of Earth. The engineers have done about the best job they can. If you look at a Starlink satellite, it kind of looks like the monolith from 2001 Space Odyssey, and it floats with the belly button of the monolith pointed towards Earth, and then out the top side away from Earth, the solar panel sticks up. And that geometry keeps the reflections from the solar panel a minimum from the view of the surface of Earth. But from a co-orbital altitude, like on the space station, that solar panel that sticks up acts like a bright reflector. And when the geometry lines up, it could be brighter than the planet Jupiter from an orbital perspective.
Wow. And you had talked about the change in the lights in cities, which it's funny that became a thing on the internet recently where everyone's like, I miss the old lighting. It looked so much more cinematic and it was great for photos. Are there any other changes that we've experienced on Earth that have changed how it appears from space? Is there anything related to population growth, global warming, anything like that?
The extent of lighting. Cities are larger in their area extent. Suburbs are sprouting up and they're all lit, particularly in Asia region where things are expanding, and the number of city lights that you see from orbit have markedly increased over, say, the last decade. So that's one of the larger effects that you could see. It's hard to see these during the day because a city during the daytime might just appear as a gray smudge. And unless you have more information, you might not be able to differentiate that from, say, a volcanic ash deposit or something like that. If you look at a city with a telephoto lens or binoculars, then you could see structure. But a lot of the cities, if you look at with just your unaided bare eye, you may not be able to distinguish them from some natural deposit.
Mm-hmm. And when you do get back from a mission, do you ever look through the images and say, oh, man, I should have done this? Or an idea comes to you after? I know it's something that happens for photographers all the time, but it's not as easy as just jumping back in a spaceship and going back up.
Yeah, and what I do is I make a list of things. Wow, I should do this on my next flight. And I did that after my flight in 2012, 2013. I made a list of stuff that I wanted to bring on my next flight. And that was fast lenses, which I did. Another thing I brought, and this is just in my personal kit, I brought one of the sync cords that you can take two camera bodies and sync them together so that when you push the shutter on one camera body, they both take a picture at the same time. And I did that specifically to document the transition from day and night. It takes about 7 to 10 seconds to go from full bright sunlight to full dark, dark, dark. And during that time, you go through many decades of brightness on an EV scale, more so than a camera on auto could accommodate. So I took two cameras and had one kind of optimized for nighttime imagery and one optimized for daytime imagery. And then I would slave them together across the day-night terminator. And I wanted them slaved together so that I could assemble the images in a high dynamic range image, and did these as sequences so you could also make them into a movie clip. And the cameras needed to be synced, because if they weren't exactly synced, the orbital motion between the exposures on two different cameras would make creating a high dynamic range image difficult to do. So that was an example of something from my 2013 flight. It's like, I want to document the transition across the day-night terminator. And then you think, how can you do it? And all I needed to do was to bring this extra cable in my personal kit.
Incredible. I got to step my game up as a photographer. I'm not pushing myself for hard enough. Now, my show notes say over 60 terabytes of raw images. That number, that's mind-boggling. Is that from your most recent mission? Is that all together? How many images are you taking and coming back with?
On this last mission, it was 7 months, 220 days. And there were 7 of us on station, 3 cosmonauts and 4, we call them USOS astronauts. There was a JAXA, Japanese astronaut on our mission, for example. But the crew together took 60 terabytes of still and video images. And the still images, I was told it's like 1.2 million pictures that we took. And I'm still in the process of getting the raw files downloaded from NASA. And on prior missions, I've got about 40 terabytes of raw files from my previous 3 space flights. So all in all, I've got about 100 terabytes of raw data that I need to juggle at home, because I don't have time at work to mess with these images. I have to mess with all my images during off hours when I'm at home.
Wow. And how does that work? What does your post-production workflow look like? That's a lot of data to comb through.
Yeah, I like to use Lightroom as a cataloger, and I've got all these images cataloged on Lightroom. I found that it's probably best to keep the catalog number down to a couple 100,000. So I've got several catalogs, one for each of my missions. And the thing I love about Lightroom is the ability to do multi-variable searches. So I could set up fields where I could search by date, I could search by camera serial number, I could search by shutter speed, f-stop, ISO, or lens. And for example, okay, I want to find some nighttime imagery of noctilucent clouds. And I would look in my notebook and it's like, okay, I use the f1.485 millimeter lens for doing the noctilucent cloud images, because that's a really good lens for seeing some of the structure, yet it gives you a wide enough field of view. And you know, the noctilucent clouds, they're primarily visible January, February period in the Southern Hemisphere. So I could go in with just a few bits of information like that, and I could set January and February and the date. I could check the 85 millimeter lens. And then if I noted the f-stop, then I'd put that in. And now this data set of a few 100,000 pictures shrinks to a few thousand pictures. And then in a postage stamp view, I could quickly go through and pick out the images I want. So knowing a few bits of information with this multivariable search, I could typically find almost any picture I can remember taking within 10 minutes.
Wow, that's a pretty narrowed down workflow. What about when you're still up on the space station? How much downtime do you have? Do you ever get to look through your images, or is it all work up there?
We work on GMT time, and we start work at 7 in the morning, and we're scheduled until 7 in the evening. And there's oftentimes another half hour to an hour worth of work. So we will work 12 to 13-hour days, typically 5.5 to 6 days a week. And any time outside of that is your off-duty time. And I spend most of my off-duty time taking the pictures or doing science investigations on my own. And I will only do enough review on orbit to verify that I've got focus, exposure, composition, things look okay. And then I just downlink the photos and I don't look at them anymore until I get back to Earth, because you could spend lots of time reviewing your photos on orbit when you should be spending that time taking more pictures.
Don, you mentioned consulting a notebook when you were searching with Lightroom and stuff. What kind of notes are you taking? Are you taking notes about all your pictures every time you're photographing?
Good question. I float around with a knee board. If you look at any pictures of me from space, you'll typically see that A, I have shorts on, and B, I've got a knee board. And if you look at that knee board, I've got a little black notebook with blank pages. And I filled 5 of those on my last mission. The mission before, I think I filled 4. And I write down notes all the time. And I refer to these notebooks extensively when I come back to Earth. And for photography, I would write down what would be great exposures, for example, noctilucent clouds or polar mesospheric clouds, or great exposures for lightning and sprites. And then I'd write down exposures for star fields and things like that. So I keep a running list of what my favorite exposures are and what exposures work well. And then I would make note of when extraordinary natural phenomenon happened. For example, we would have some events with high solar activity where the aurora would just be outstanding. So I would make a note, February 3rd, 2025, strong aurora. So that way, if I wanted to go back and look at aurora, I could choose a range of dates like that, choose some of the wide angle lenses at f1.4, and boom, I've got a few thousand pictures of nothing but aurora.
Wow, interesting. And just for all of our listeners out there, I had to go on to a quick Google search. And yes, John, you're right. Shorts. And the knee tag
And you
there.
see that knee board that's stuck to my left leg, and I'm always writing in that, not only photography notes, but I would write down temperatures and pressures and relative humidities, and we do analysis of our potable water system. I'd write down how many part per billion impurities. So if you ever needed to go back and say, gosh, what's the relative humidity on station? And, I've got that all written down in my notebooks.
Wow. I want to shift gears a little bit, bring us back down to Earth for 2007, a different kind of expedition, this time to Antarctica. You were hunting for meteorites, right? Were you able to take any images? Can you talk a little bit about that expedition?
Yeah, I was fortunate enough to be on the ANSMET. It's the Antarctic Search for Meteorites. It's co-funded by the National Science Foundation and NASA. And every year they send 2 groups to Antarctica to either survey for future sites to do detailed meteorite recovery, or to go to past sites that have been surveyed to actually do the meteorite recovery. And I was on one of those groups, and we spent about 6 weeks living on the ice. and we recovered over 850 meteorites.
Wow. That is wild. Now, out of everything you've seen out there, when you're working on these experiments and you're seeing things that, again, most of us aren't privy to, is this inspiring the creative side of your photographic work?
Oh, it does. When you are in a frontier environment that's off of paved streets and sidewalks, it strikes me in a way that makes me want to record it with imagery, and it gets your creative juices going. And in Antarctica, for example, we were camped out on these areas of blue glacier ice. And it's a virtual desert in the interior of Antarctica where the snow gets blown off of the ice, and it's just this robin egg blue. It is just totally amazing to be living and working on nothing but blue ice for as far as you could see. And it's tough to figure out how to pitch a tent when you're on this blue ice. And there are some areas that if you find a rock, it's a meteorite.
Mm-hmm. What else could it be? Yeah. By the way, when you're looking out a porthole on the ISS and looking at the night sky, how does that compare to the darkest regions of Earth looking up, like Antarctica? Is it much different, or is it pretty similar?
It's similar. You're looking either at Earth or the sky. The perspective is different. On station, your horizon is about 2,000 kilometers. So you see things of the order of half a continent. And with your boots on Earth, maybe 50 to 100 kilometers is your horizon. So your perspective is different. And aurora is an example. With your boots on the ground taking pictures of aurora from Earth, you see these amazing displays of green and reds. But it's different from orbit because your perspective sees a much wider view, and you can see a separation of the green and the reds. You can see that the reds are above you or at your orbital altitude, and the greens are below you, and you're flying over them. It's a different perspective of the same animal. It's like the blind men feeling the elephant, and they're each making an observation, but they're doing it in a different way, and they're all complementary. Let me point out, in terms of these complementary views, I worked with a world-class astrophotographer, Babak Tafreshi. He's from the Boston area, and he does amazing imagery from Earth. And I've known him for decades. And we had a project together where through email and texting from orbit, we could do synchronized imagery, maybe a comet, maybe aurora, maybe a Milky Way, where we would be looking at the same phenomenon, but his perspective would be Earth, and my perspective would be from orbit. And we've put together a whole series of images of this, and we call it From Above and Below. And it accents the difference between what you could see on Earth versus what you could see in orbit.
That's cool.
Wow, that's amazing. That sounds like an incredible book.
This effort was partly sponsored by National Geographic. In the October issue, they had a spread of From Above and Below in that issue. And we're talking with them about trying to publish a book on this. We've got enough material to publish a book, so we'll see whether we can make that happen.
That's so cool.
That would be great to see. I know. Over 590 days in space, all these terabytes of images. Is there any unicorn out there that's eluded you? The shot you want that you just haven't captured, or haven't captured the way that you would want to?
Yes, there are. I like that, unicorns in space. Next time I fly, I've got a list of shots that I want, and I know the little bits of equipment that I need to bring. There are mounting brackets and arms that would make setting up and synchronizing cameras a lot easier. If I get a chance to fly again, I'll throw some of those in my personal kit. More of these synchronizing cables so I can have two cameras simultaneously taking images. On my last flight, I only flew a 30 centimeter cable because I figured I'd have the cameras side by side in the same window. But it became obvious that I needed to be able to set cameras up in adjacent windows. So I need to take a longer synchronizing cable, and that will allow me to do a different level of exploring. Faster lenses, if I could get a f/0.95 lens that's wide angle, man, I'd love that. So I've got this a wish list of gear and a shot list of images that I want to try to continue to capture.
So it's not just all, I'm Don Pettit. I can take some bubble gum and this scrap metal over here and take whatever I need.
Yeah, it is amazing. The imagery that I've been able to do has involved a lot of colleagues, from the photo TV people at Johnson Space Center that actually train us and make sure that we have the state-of-the-art equipment, to colleagues at universities like at RIT and other places that help me with the detailed imagery. Example of another photo I want to get, I'd like to image the sodium tail of the planet Mercury. And I thought I was going to be able to do that with the filters I brought, but it just didn't quite work out. So now I know, working with some amateur astronomers from Europe, what I need to do on another mission if that chance comes about. So it's not just me up on orbit snapping away. It's me working with amateur astronomers and people down here on Earth and the photo TV people at JSC. And all of us together are what allows the imagery that I'm the lucky one that manages to collect.
I love that. It's a true collaboration. Now, that being said, there's so many people out there that are looking up to you and inspired not only by the images you're taking, but really just everything about you. You're such a charismatic person. The intelligence, the way that you relate this to just everyday people is so inspiring. Don, what advice would you give to somebody who may or may not want to be in space one day, to chase their dream and to really, from a photography perspective or not? What's some advice you'd give?
I'm a big proponent of the concept of a frontier. And my frontier happens to be space, but there are frontiers all around us. It could be the bottom of the ocean, the stratosphere through the eyepiece of a telescope. It could be in your backyard looking at what's going on in the tall grass zoo that especially hadn't mowed in a while. There's all kinds of stuff going on. You just have to open your eyes and make observations. And one aspect I like to point out from space, I've got a picture of Earth out one of the windows. And I point out that hundreds of astronauts have taken tens of thousands of pictures out this window. And you could think that, well, why should I even take a picture out this window? Because it's already been done. But your brain and your eyes and your ability to think is different than all those other hundreds of people that have been there before you. And you can make an observation that nobody else has happened to make simply by the way you look out that window or the way you set your camera up. So just explore the frontiers that present themselves to you, the frontiers that you're motivated to go to, and just open your eyes and collect data, and then record or write about it. Because you could make an observation, and if you don't somehow share that with others through publications or imagery, it's almost as if it's never been done. So record your observations, write them down, publish, and share the information with others.
Wonderful advice. And I love that idea of frontiers. Don, what's next for you? You hinted it a couple minutes ago. You said if you ever go back up there again, do you have any plans to return to space anytime soon, or any projects that you're working on?
I'm still an active astronaut, and I'm turning back into an Earthling. And I am going back into the basic training that astronauts need to do in order to maintain your currency. So I'm back in the standard training flow of all the other astronauts in the office, and I'm working on a technical ground job right now. I'm going to be working on the crew aspects of the lunar rovers that we're going to send to the moon in the Artemis program. And gosh, I couldn't ask for a better means of employment right now.
Mhm.
Well, for all of our listeners out there, if you do not follow Don on Instagram, he is active on Instagram, astro_Pettit, Pettit. Is that the best place to keep track of what you have going on, Don?
Yeah, that I've also got an X, and then I post more technical details on Reddit under the astrophotography. And one of the neat things I like about the astrophotography thread on Reddit is you are required to put the photographic details of your images. So you write down your gear, your exposures, all of that information along with the photograph that you have posted. And that's good for the technophiles that are around.
Wonderful. Well, Don, this has truly been a treat. I want to thank you, the entire team at NASA, and anybody else who has helped facilitate this conversation.
Well, it's a pleasure and an honor to be able to talk with you all. And I could talk for hours about space and photography and what it means to do exploration. So this has been a treat for me.
Wonderful, wonderful. And to all of our listeners out there, thank you again for joining us today. If you are a fan of the show but are not yet a subscriber, head on over to Apple Podcasts, Spotify, B&H's YouTube channel, or wherever you get your podcasts and click subscribe. You can also find us on the Explorer blog where we post photos from our guests along with our show notes. I'm your host, Derek Fosbender. Jill Waterman is our creative producer. Episodes are recorded, mixed, and edited by technical producer Mike Weinstein, and our executive producer is Richard Stevens. On behalf of us all, thank you so much for tuning in today.
Thanks to NVIDIA for sponsoring this week's episode.